Black holes are truly fascinating objects in space. Imagine a huge amount of stuff squeezed into a tiny, tiny spot. This creates a super strong pull called gravity. It is so strong that nothing can escape, not even light, the fastest thing we know. That is why they are called black holes. They completely trap everything that gets too close. It is a one-way trip into darkness. Most black holes are born from giant stars. These are stars much bigger than our sun. When these huge stars run out of fuel, they die. Their own gravity causes them to collapse inward. This collapse is incredibly powerful and sudden. It squeezes the star's core down to an amazing degree. If the star is big enough, it becomes a black hole. Our own sun is too small for this. It will not become a black hole when it dies. A key part of a black hole is its event horizon. You can think of this as its point of no return. It is not a solid surface you could touch. Instead, it is an invisible boundary in space. Once something crosses the event horizon, it cannot get out. The black hole's gravity is just too powerful there. Light itself cannot escape from inside this boundary. This is what makes black holes invisible to us directly. It is the edge of the known and the unknown. At the very heart of a black hole is the singularity. This is a point of almost unbelievable properties. Scientists think all the black hole's mass is crushed here. It is squeezed into an infinitely small, infinitely dense point. Our current laws of physics struggle to describe it. What happens at the singularity is a huge mystery. It is a place where space and time might behave strangely. Understanding singularities is a big goal for scientists. It challenges our understanding of the universe. It is the ultimate core of the black hole's power. Since black holes do not give off any light themselves, scientists have to be clever to find them. They cannot just look through a telescope and see one. Instead, they look for the effects of the black hole. They observe how a black hole affects things nearby. For example, gas and dust might be pulled towards it. This material heats up and glows brightly before vanishing. This bright glow can be seen by telescopes. Stars orbiting an empty spot can also signal a black hole. Their dance reveals the unseen massive object. Another amazing way to find black holes is through gravity. Not just the pull on nearby stars, but something bigger. Sometimes two black holes can spiral towards each other. Eventually, these two black holes will merge and combine. This huge cosmic crash creates ripples in space and time. These ripples are called gravitational waves. Special detectors on Earth can sense these tiny waves. It is like hearing the universe shake from far away. This confirmed that black holes really do exist and collide. It opened a new window to study these objects. There are also supermassive black holes, real giants. These are not just a few times the mass of our sun. They can be millions or even billions of times more massive. Imagine the weight of billions of suns in one place. Scientists have found these giants in a special location. They are located at the centers of most large galaxies. This includes our own galaxy, the Milky Way. Our galaxy has a supermassive black hole at its heart. It is called Sagittarius A. That said, A star. It is a fascinating object for astronomers to study. These supermassive black holes play a very important role. They seem to be connected to how galaxies themselves form, and also how galaxies change over billions of years. The exact way this works is still being studied, but it seems the black hole and its galaxy grow together. Sometimes the black hole can affect star formation. It can either trigger new stars or stop them from forming. Understanding this link helps us understand the universe's history. These giants are not just there, they shape their surroundings. They are active players in the lives of galaxies. Black holes are known for eating things. They can pull in interstellar gas and clouds of dust. If a star wanders too close, it can be torn apart. The material from the star then spirals into the black hole. They can even consume gas from nearby galaxies. It is like a cosmic vacuum cleaner, but much stronger. Anything that crosses the event horizon is added to its mass. This makes the black hole grow even bigger over time. The more it eats, the more powerful its gravity becomes. This process of eating is called accretion. Sometimes black holes are not neat eaters at all. When a lot of material falls towards a black hole quickly, it can get very messy around the event horizon. Not all the material falls in directly. Some of it gets superheated and shot back out. These are powerful jets of gas and particles. These jets can travel at nearly the speed of light. They can stretch for thousands of light years into space. These jets show how much energy is involved. They are some of the most energetic events in the universe. The idea of black holes started a long time ago. It began with theories about gravity and stars. In 1930, a scientist named Subrahmanyan Chandrasekhar made a calculation. He figured out that very large stars would collapse. After they used up all their fuel, gravity would win. They would collapse under their own immense weight. This was one of the first hints of such strange objects. At first, many scientists found the idea hard to believe. The thought of something so dense was shocking, but the math pointed towards their existence. Over many years, more evidence started to build up. Telescopes observed stars moving in ways that suggested black holes. They saw X-rays coming from areas where black holes might be. Then came the detection of gravitational waves. These waves were direct proof of black holes merging. This was a huge confirmation for scientists. In 2019, something even more amazing happened. The Event Horizon Telescope captured the first actual image. It was a picture of the shadow of a black hole. This made black holes more real than ever before. Black holes are incredibly important for science. They are like natural laboratories in space. They allow scientists to test big ideas about the universe. One of these big ideas is Albert Einstein's theory of general relativity. This theory describes how gravity works and how it affects space and time. Black holes have extreme gravity, perfect for testing this theory. So far, Einstein's ideas have passed all the tests. Studying black holes helps confirm our understanding of gravity. They push the boundaries of what we know. They help us explore the very fabric of reality. Beyond testing gravity, black holes help us understand more. They teach us about extreme physics, things we cannot create on Earth. They provide clues about how stars and planets grow. They might even help us understand how fast the universe is expanding. Scientists are also trying to connect different big theories in physics. Black holes are a key place where these theories meet. Understanding them could lead to new breakthroughs in science. They are not just curiosities, they are fundamental. They hold secrets about the universe's past, present, and future. Each discovery about them adds a piece to the cosmic puzzle. Even with all we have learned, many questions remain. Scientists are still trying to figure out all the details. For example, what exactly do black holes consume most often? And what happens to matter as it falls right into a black hole? The moments just before it crosses the event horizon are mysterious. How do supermassive black holes really shape their galaxies? The exact mechanisms are still being researched actively. What happens inside the singularity is a huge puzzle. Our current physics cannot fully explain that tiny point. These questions drive scientists to keep exploring. Finally, let's clear up some common myths with cool facts. Many people worry if Earth will fall into a black hole. The good news is, Earth is not in any danger. There are no black holes close enough to threaten us. Another question is about our sun. Will our sun become a black hole? No, it will not. Our sun is too small to collapse into a black hole. It will end its life as a much calmer white dwarf star. So, while black holes are powerful and mysterious, we can study them safely from a great distance.